You know, large language models, they really do feel like magic, don't they? I mean, they can write poetry, they can debug our code, they can explain quantum physics. But underneath that amazing surface, there's a deep, deep mystery, a true black box. So today, we're going to pull back the curtain and peek inside. I mean, think about it. We use this stuff every single day. We rely on it for answers, for creativity, for work. But that brings up a really big question. Do we have any clue what's actually going on inside its head? Can we really trust it if we can't see the gears turning? Let's find out. All right, so to kick things off, we've got to zoom way in on the fundamental challenge here, which is just trying to interpret what an AI is doing internally. And it turns out the biggest hurdle has a pretty specific name. And that name is polysemanticity. Yeah, I know, it's a mouthful. But the core idea is actually pretty straightforward. You see, unlike our brains, which are pretty good at organizing concepts, AI neurons are, well, they're messy. A single neuron can fire for completely unrelated ideas all at the same time. And this slide gives you the perfect way to think about it. Your brain is kind of like a neat filing cabinet. The neuron for cat is in the cat drawer. Simple. But an AI neuron, it's like a junk drawer. And I mean a real junk drawer. Researchers found one single neuron that lit up for academic citations, and for Korean text, and for HTTP web requests. I mean, how on earth are you supposed to make sense of that? It's chaos. Okay, so if the AI's brain is just a bunch of these messy junk drawers, how do we ever figure out what's going on? Well, researchers have come up with a seriously clever tool to do just that. Think of it like an AI Rosetta Stone. It's called a Sparse Autoencoder, or SAE for short. So here's how it works, basically. The SAE grabs that jumbled, chaotic signal from the neuron. Then, it forces that signal through a special filter that only lets a few distinct ideas or features get through. And here's the brilliant part. The SAE then proves it understood by perfectly rebuilding the original messy signal using only those few clean features it found. It's literally untangling that junk drawer, pulling out each item one by one so we can finally see what's inside. And the stuff they're finding with this, it is absolutely wild. By using these SAEs on huge models like GPT-4 and Cloud 3, researchers are pulling out these incredibly specific human-level concepts. They found features for things like sycophantic praise, you know, when the AI is just being a suck-up, or the abstract idea that humans have flaws. They even found features that only turn on when the model's asked to translate something. For the first time, we're actually starting to map the mind of the machine. So that's what's happening on a micro level, inside a single neuron. But let's zoom back out. What happens when you take these incredibly complex systems and stress test them in the real world? This is pretty cool. In what was basically an unprecedented move, OpenAI and Anthropic, two of the biggest players in the game, agreed to try and break each other's models. Yeah, they literally red-teamed each other, actively looking for all the cracks, the biases, and the safety failures. And here are some of the top-line results from OpenAI's side of the evaluation. You can see that Anthropic's Claude models were amazing at following really complex instructions. OpenAI's models, on the other hand, were tougher against jailbreaks. But honestly, the most interesting part? It's how they each deal with truth, and what happens when they're not sure about something. And this right here reveals a huge difference in philosophy between the two companies. Anthropic's models are built to prioritize being certain. Get this, on really tough questions, they would just refuse to answer up to 70% of the time, just to avoid being wrong. OpenAI's models are tuned for utility. They'll answer way more often. Now, that means they get more correct answers overall, but it also means they hallucinate more often. It's that classic trade-off, right? Do you want to be more helpful, or do you want to be more certain? These tests also uncovered some really subtle but super effective vulnerabilities. Take this past tense jailbreak, for example. If you ask an AI for harmful information right now, it's trained to refuse. But just by changing the tense, by framing it as a question about the past, well, that turned out to be a clever little loophole. So what happened? Claude didn't see a request for harmful instructions. It saw an educational question about history. And so it gave a detailed, factual list of historical tactics. It totally bypassed its own safety training. And it all came down to that one tiny three-letter word, were. Okay, so all of this brings us to our final and maybe most important piece of the puzzle. Because look, understanding how an AI thinks and talks, that's one thing. But the whole game is about to change. We're entering the age where AI starts doing things. And this quote from Foundation Capital just nails it. The big push right now isn't just about generating better text or images.
It's about getting AI agents to actually do work for us, to execute entire workflows from start to finish. We're talking about a massive shift here, not just a small upgrade.
And when you make that shift, you get a whole new kind of data. It's called a decision trace. It's not just about the final result anymore. The real value is in the whole journey, a step-by-step, replayable history of every bit of information the agent used and every single action it took. You're basically getting a perfect map of how your business, or even just you, actually gets things done.
But as you can probably guess, giving AI the power to act on its own opens up a huge can of worms. Our entire security world is built for software that just sits there waiting for us to tell it what to do, not for software that has its own agenda. And then you've got the huge legal questions, right? Who's on the hook when an autonomous agent makes a mistake? It even changes the business world, because big companies could try to cut off data access to stop startups from building powerful new agents.
And all of this leads us to one final, really critical question. As we move from just talking to AI to actually letting it act for us, booking our travel, managing our money, running parts of our businesses, we are handing over more and more of our own decisions. So as we hand over the keys, the question we really have to ask ourselves is, who's actually in control?